Hey there, fellow makers and electronics enthusiasts. Ever wondered what makes your gadgets tick? It all starts with a steady supply of DC power. Today we're going to demystify the process and show you how to build your very own DC power supply faster than you can say electromagnetism. Building a DC power supply is a fundamental skill for anyone interested in electronics. It's like learning the ABCs before you can write a novel. But fear not, this isn't some complicated engineering feat. We'll guide you through each step, making it fun and easy to understand. Get ready to unleash your inner maker and bring your projects to life. So roll up your sleeves, grab your tools, and let's dive into the exciting world of electronics. By the end of this guide, you'll have a working DC power supply and the confidence to tackle even more ambitious projects. Before we start building, let's gather our trusty sidekicks, the components that will form the backbone of our DC power supply. Don't worry, we won't be needing anything too fancy. Here's your shopping list. First, a transformer. This hefty fellow takes the AC power from your wall outlet and steps it down to a lower voltage, making it safer to work with. Next, a rectifier. Think of the rectifier as the bouncer at an exclusive DC club. It only lets DC current pass through, blocking any unwanted AC intruders. Then, the filter capacitor. This smooth operator smooths out the DC output from the rectifier, ensuring a clean and stable power supply for your circuits. You'll also need a voltage regulator. Like a strict librarian maintaining order, the voltage regulator keeps the output voltage constant, protecting your delicate electronic components from power surges. And finally, some basic tools. No need for a NASA-grade workshop. You'll only need some basic tools like a soldering iron, solder, wire cutters, and a multimeter. With these components and tools at the ready, we're all set to start assembling our very own DC power supply. Get excited, because things are about to get electrifying. Now that we've met our component crew, let's understand how they work together in perfect harmony. Think of the circuit as a well-choreographed dance, with each component playing a crucial role. First, the AC power from your wall outlet enters the transformer, which steps down the voltage to a safer level. This lower voltage is then fed to the rectifier. The rectifier then converts the AC voltage into pulsating DC voltage. It's like turning a wild dance party into a more organized line dance. However, this DC voltage is still a bit jumpy. That's where the filter capacitor steps in. The filter capacitor smooths out the pulsating DC voltage, much like a skilled dance instructor guiding the dancers into a smoother rhythm. Finally, the voltage regulator ensures a constant and stable DC voltage output, like a conductor keeping the orchestra in perfect sync. Understanding this flow of energy through the circuit is key to building a successful DC power supply. Don't worry if it seems a bit complicated at first. As we start assembling the circuit, it will become crystal clear. Section 4. Building your powerhouse, assembling the circuit. Alright builders, it's time to put our knowledge into action and assemble our DC power supply. Don't worry, we'll guide you through each step. Just remember to wear safety glasses and take your time. First, connect the output of your transformer to the input of the rectifier. Make sure you connect the wires correctly, respecting the polarity markings on each component. Next, solder the rectifier's output to the positive and negative terminals of the filter capacitor. This capacitor will act as our smoothing agent, ensuring a clean and stable DC output. Now connect the positive terminal of the filter capacitor to the input of the voltage regulator. The voltage regulator will maintain a constant output voltage, protecting your circuits from any unexpected power surges. Finally, connect the output of the voltage regulator to your output terminals. These terminals will be the source of your clean and stable DC power, ready to power up your projects. Remember, soldering is like a delicate dance between heat and precision. Take your time. Practice on some scrap components, and soon you'll be soldering like a pro. Section 5. Testing time. Is your DC power supply alive? With our DC power supply assembled, it's time for the moment of truth testing. This is where we find out if our creation truly works or if we need to do some troubleshooting. Grab your trusty multimeter and set it to measure DC voltage. Connect the multimeter's probes to the output terminals of your power supply. If everything is connected correctly, you should see a stable voltage reading on the multimeter's display. The voltage reading should match the output voltage of your voltage regulator. If it doesn't, double-check your connections and make sure all the components are soldered correctly. Sometimes, a loose connection or a cold solder joint can be the culprit. If your power supply is working correctly, congratulations, you've just built your very own source of DC power. If not, don't despair. Troubleshooting is all part of the learning process. Section 6. Unleash your inner engineer. Conclusion and call to action. Congratulations, you've successfully navigated the exciting world of electronics and built your very own DC power supply. Now you have the power to bring your electronic dreams to life. Remember, this is just the beginning of your maker journey. Experiment with different components, explore new circuits, and never stop learning. The world of electronics is vast and full of endless possibilities. If you enjoyed this guide, give it a thumbs up, subscribe to our channel for more exciting projects, and share your creations with the world. Keep tinkering, keep exploring, and never stop asking how. Until next time, happy making.